Okay, class, we're about to start section 2.2, finding equations of linear models. We have objective 1, finding linear model equations by hand. The FBI gathers and publishes data about the burglary rate in the United States, which is the number of burglaries per 100,000 residents. For each year, according to their statistics, the crime rate for burglaries were 1,168 in 1992 and 702 in 2011. It says find the linear model by hand for the burglary rate B equals f of t at t years since 1990. So this is our equation model. We have B is equal to m times t plus b. We basically took the y equals mx plus b and substituted in b for y and t for the x value. Okay, so now what we have to do is this here. We have to find the slope, or the m. Now remember this here. We must first have two ordered pairs. Now our ordered pairs are listed here. Okay, first of all, this 1,168 in 1992, remember the year is the independent variable and the amount of burglaries are the dependent variable. So this is since 1990. So 1992 would actually be 2, and then we would have 1,168. Now our next ordered pair, 2011, we know that's 21 years since 1990, and then that'll be 702. So now we would substitute. We know this would be, it used to be y2 minus y1 and x of 2 minus x of 1, but we will use the variables that we're using for this particular problem. So it'd be b sub 2 minus b sub 1 over t sub 2 minus t sub 1. So that would equal, we have 702 minus 1,168 all over 21 minus 2. Now remember, I tell you when you substitute, put in what you substitute in parentheses. Now when we subtract, we will have a negative 466 divided by 19. Now negative 466 over 19 will give us a negative 24.52. Now, remember, this is our slope, is negative 24.52, but we have to find our b here. So this is what we would do. We would do some substitution. So I would suggest that we use this second order pair here. So we would take our b equals m times t plus b, and our b here would be 702 is equal to our m, which would be negative 24.52, and our t would be 21, and that would be plus b. So we have 702 is equal to a negative 514.9 plus b. Now we would add 514.9 and that would give us 1,216.9 equals b. So now we can write out our equation. We will have b is equal to negative 24.52 t plus 1,216.9. And that will be our final answer. Now we scroll down here to b. It says, what would the model predict as the crime rate in 2015? So we would take this equation again. B is equal to a negative 24.52 t plus 1,216.9 Now remember, our t is based off years past 1990, so that would be 25, because it's 25 years from 1990 to 2015. So we have b is equal to a negative 24.52 times 25 plus 1,216.9. So when we add all this together, this will give us 603 per 100,000 residents. Now we have C. It says, what would the model predict the burglary rate for 800 per 100,000 residents? So basically, we would take the same equation. B is equal to a negative 24.52t plus 1,200, supposed to be 16.9. Now, we know what our B is. Our B is 800, and it equals to negative 24.52t plus 1,216.9. So the first thing we would do is subtract 1,216.9 on both sides. And that would give us a negative 417.1. And that would equal to a negative 24.52t. We divide each side by a negative 24.52. And that will give us t to be approximately 17.00. Now remember, we're doing years according to past, starting from 1990. So what we will have to do off to the side is take 1990 plus those 17 years, which will give us 2007. So 2007 will be our final answer. Okay, now it says Objective 2, finding linear regression equations by calculator or computer. Example 2, consider the FBI burglary data set again. The following table shows the U.S. burglary rates for many years, and a scattergram of the data has been drawn below. Label the skeleton axis on the scattergram appropriately. Recall T years since 1990, and this right here is considered our starter year. Says draw the graph of the linear model found in example 1. Does the linear model found in example 1 do a good job of modeling these data? That is, does it come close to all the data points? And D, what would make a better linear model for these data than the one found in example 1? So let's scroll down here. Now, what you have here, I took the liberty of already labeling the axes. Now we know the burglary rate would be per 100,000, which is listed here. And then we have the years since 1990, which is listed here. So this is what happens. When you go back to example 1, which was on the previous page, we can scroll back there really quick. Okay, now with example 1, we started in 1992 and we went to 2011 and we had our ordered pairs here. So the line that's drawn on this graph represents those 2 points. So we will scroll down. And also, before we get down to the graph, the other points are drawn based upon these points here. So this right here will be your x value and your y value, or your t value, and also your b value. So, plotted all of these points. This is the point from example 1, and this is the other point from example 1. And I drew this line here. Now, what we have here is this here. We go back up here to these questions. It says, does the linear model found in example 1 do a good job of modeling these data? If you notice, all the other points are below this line. So the answer is no. The answer is no. Line does not include the other points all the other points are below the line. Next, what would make a better linear model for these data than the one found in example 1? Okay, we use the calculator to find a line that balances all the points. Now, this is where, remember in the last section, I told you all we would get to how we get these lines on these scattergrams. This is where linear regression comes in. Now, let's read these directions here. It says linear regression line is the linear model that best fits all the given data. Remember I called that line back in 2.1, I called it a best fit line. This is where you're going to learn how to do linear regression in your calculator to get a best fit line. The process of finding this line, called regression, is a complicated statistics topic and will not be covered in our course. We will use calculators or computers to find the linear regression equation. The line has many other names, including linear regression function, regression line, line of best fit, least squares regression line, and least squares line. Note, we will learn other models in later chapters that might work even better for this data set. Okay, now we go on to the next page. On the next page, we have the TI-84 instructions. So you can read all of this at your leisure. You can pause the video, read this, or go to the YouTube video listed here, and you can find this video. Now, I need you at this moment to pause this video. Go and watch the video on how to set this up in your calculator. Now, after you have paused this video, set it up in your calculator, there are also Excel instructions. And you can read this at your leisure, and it also gives you the website for that as well, for the Excel instruction. So you can pause this, play a little around with it on Excel so you could get a better idea of how to do this on the calculator and Excel. Now we come down here to example 3. Example 3, it says consider the FBI burglary data set again. The following table shows the U.S. burglary rates for many years. Let B equals F of T be the burglary rate per 100,000 residents at T years since 1990. Find the linear regression model for B equals F of T. Now, if you put this in your calculator as I stated earlier, using the examples that was given, you would have B is equal to negative 21.51 T plus 1,082.79. Now that's rounded to 2 decimal places. It says, what would the linear regression model predict as the crime rate in 2015? Is this interpolation or extrapolation? So we would take this formula here. We have B is equal to negative 21.51 T plus 1,082.79. Now, we will substitute. Now, we know this is years since 1990, So we'll take 2015 minus 1990, which will give us 25. So our t would be 25. And now